Boa tarde. Good afternoon. This is going to be in English, so I'm sorry, Brazilians. Well, my name is Matheus. You might know me from Twitter. I work for the consultancy company called Thoughtbot, and you might like us, you might know us from FactoryBot, and today we're gonna talk about async Rails. I know it's late Friday, everyone is waiting for the happy hour, but bear with me, I have something special for us. Maybe you know a lot about async Ruby, maybe you know nothing about it. So I split this talk into 3 parts, and each part will build on top of the previous one. So even if you don't get everything, you will still be able to take something out of this. Feel free to take notes, but I will also share the slides later. Okay, before we take into the async train, I want you to make sure that we have the basics down. So let's start with the first chapter. What is async programming in the first place? You might have some kind of intuition about it, like it's stuff running at the same time, something like that. And it's kind of true, but we'll need to be more precise than that. We have to discuss the difference between concurrency and parallelism. And I'll try to put it very simple. Concurrency is taking turns, and parallelism is independence. That's it, taking turns versus independence. Let's try with an example. So imagine 2 kids. You have 2 brothers, 2 siblings, and they like to play video games, but there's just one controller available. So what do? Well, they can take turns. One kid plays one level, the other kid plays the other one. And that can work really well if the kids are fair, if the kids are wanting to share. We call this cooperative execution. But if the kids are selfish, you know what happens. One kid starts playing everything. So in this case, we'll need some kind of supervisor for them. In the async world, we call this schedulers. Schedulers basically decide how much time each kid has and make sure that everyone is having their share of time. We call this preemptive execution. Okay, next problem. What if the kids don't want to play the same game? Well, they can just change the game when they assume their turns, but that means that you are using now time to change games instead of playing games. So you lose some time and some momentum in that context switch. So you might hear that this is not good enough. They want to play games at the same time. In other words, they want independence. And independence means parallelism. To have parallelism here, we need 2 separate streams of work. So in this example, we would need 2 separate consoles. One kid wants to play a different game, fine, they can just change it. The context switch is still there, but only for the kid changing games. Okay, let's do a quick review. Concurrency means taking turns, parallelism means independence. That's the basics. We can now move on to the second chapter. Let's talk about async Ruby. There are a lot of Ruby implementations. We heard about mRuby, there's cRuby, jRuby, truffle Ruby, and this talk is going to be cRuby specific. And if you don't know what you are using, then it's probably cRuby, don't worry. The landscape of Ruby and async programming is very diverse. On the concurrency side, we have threads and we have fibers. And on the parallelism side, we have vectors and processes. And we'll talk about all of them here. Starting with fibers. Fibers are kind of like methods, but you create one with .new and a block. And to call it, you call it with resume instead. The special thing that they have is this thing called fiber.yield. And what it does is, think about it like a soft return. The next time you call this fiber, instead of starting at the beginning, it will start actually where we left off the last time. So in this case, if we call it resume once, we get I'm playing stage 1. And if we call it again, we get I'm playing stage 2. So it's kind of like a checkpoint. Let's see how fibers could help our kids. So we could define a fiber for them to take turns like this. We can define a current stage variable, and then create a new fiber. And this fiber has this infinite loop, so we can take as many turns as we want. And inside the loop, we basically print the current stage, and then we increment that variable and return with fiber.io. The other kid fiber would be exactly the same thing, but with a different emoji. If we do this 5 times, for example, we get the kids to play and take in turns. That's pretty simple. And the cool thing is that we have control when the fibers switch. So, for example, if you like one of the kids more than the other, you can make it play more than the other, and fibers will get you to do that. With fibers, you are the scheduler. You get to decide. Let's see threads now. They look similar to fibers. You also create with .new and a block, but they start running automatically. If you need to wait for them, you have to call join. So what? What's the difference? Maybe you have like some code that takes a long time to execute, and you think, maybe, I don't know, Fibonacci, calling it twice in a row. I know that's very realistic. And let's pretend it takes like 1 second for each call. So you think, I'm not going to use a thread, and each thread will take 1 second, and they will run in parallel, and it will be fast. But if you try to do that, you'll see that it's 2 seconds. We expected that the threads would run like this, but we actually got this. And that's the thing with CRuby. The threads in CRuby don't run in parallel. They actually switch automatically on I/O. And if you don't know what I/O is, it's basically whenever you reach for something external. It's like a side quest that you have to do, like doing a system call or connecting to a socket. So if instead of Fibonacci, we had something that it's not CPU bound, for example, a sleep call, which is I/O bound, then yes, they would run in 1 second now. It looks like they ran in parallel, so did I lie? Oh, actually, no. If you notice, the green part, it's written executing in green and I/O in purple, but you can see that. But the green part, the part that Ruby is actually executing, never overlaps. So CRuby never runs those 2 threads in parallel, but they are waiting in parallel. And the cool thing about that is, like I said, it works for any kind of I/O. It works for sleep, it works for reading files, it works for HTTP requests, it works for database queries. With threads, it's like you have a babysitter that can help you. Let's see how threads could help our kids. So mom was worried about the health of their kids, so she came up with a rule. You play a stage, then you have to run around the block. And to simulate the running around the block, we'll basically sleep for a second. And that seems like the perfect use case for threads, because if we don't switch on I/O, then a kid has to play a stage, then run around the block, and only when the kid stops running, the other kid can start playing. But if we switch automatically, then as soon as the first kid starts running, the second kid can start playing. So that's much more efficient. The code, it's very similar to what we did with fibers, but we create threads instead, and we wait for threads to finish before we create new ones. And if we do that, it runs in about 5 seconds. And that's because most of the time we are just waiting on those sleep calls to complete. And we do that 5 times, then 5 seconds. So it looks like threads are actually great, right? Well, if you ask anyone that worked with threads before, they will tell you no. If you look at the output of that code, it's kind of weird. The kids are always playing the same stage, and the stages move in odd numbers for some reason. And the reason is because this code has a race condition. It comes from this part of the code. We are reading and writing to the current state variable in 2 steps. We call this a non-atomic operation. So the CRuby VM might change threads after you read the variable, but before you increment it. So you get the threads running in weird orders. So one way to fix that would be creating a mutex, then adding this synchronized block, which basically means inside this block, do not switch threads. Then you put the printing and the incrementing inside the block. but you put the sleep call outside of the block so threads can wait in parallel, and then you would get the right result in the right time, 5 seconds. But that's the thing with threads. They are just hard. Or if you want to be more precise, shared mutable state is bad. And if you agree with that, then you might like rectors. Because with rectors, you can even access local variables. They will raise. You can even access constants. They will also raise, because in C Ruby, you can modify constants. So to make this work, you would have to either freeze the constant, which makes it immutable, or you have to pass the variable in the rector constructor, which will make a copy of it, and you can only use the copy that you have, not the original value. Like this. Rectors like and need independence, which allows them to run in parallel. It's like we have the 2 kids, but they have 2 rooms, 2 consoles, 2 games. There's 2 of everything. Everything is separated, but they still live in the same house. Rectors are cool, but the thing about them is that they are still experimental, which means that basically they have bugs. So it's not super safe to use them in production. So we are left with processes to do parallelism in Ruby. And they work like this. They are very similar to the other ones, but we create a process with process.fork and a block. And to put it simple, when you reach that line, Ruby will basically create a clone of all of your app in a new process. It's like you have the kids, you want them to play in parallel, so you build 2 new houses, you clone their family twice, and then send each kid to each new home. Yeah, it kind of works, but it's as heavy as it sounds. So you don't want to do that a lot. So that's the landscape that we have currently. And if I would put that in a chart with the x-axis coming from current to parallel, and the y-axis from easy or light to hard or heavyweight, we could have fibers as very easy and light, but only concurrent. We have threads, which are not actually parallel, but at least they switch automatically on I/O, so you can wait in parallel, but they are a little heavier. Then we have rectors, which are truly parallel, but they are cumbersome because everything has to be immutable, and we are just not used to doing that. And lastly, we have processes, which are also parallel, but quite cumbersome and heavyweight. And to complicate matters further, in Ruby 3.0, we had this thing called blocking fibers. And in short, you can basically make fibers switch on I/O just like threads, but you have to write the scheduler and use the fiber scheduler interface for that. Luckily, someone did that for us, so there's the async gem that wrote the scheduler for us, and now basically fibers can be pretty much like threads, switching on I/O, but more lightweight. With that, we can finally arrive at the third station, the thing that we were all waiting for, which is async Rails. How can we use async or apps, and how does Rails use it for you? First, there will be a disclaimer. There's code here, and there will be code examples, but I don't want you to focus on the code. I want you to focus on the principles that I'm going to teach you, because the principles are more important. Principles apply to any app and basically any programming language, not just Ruby, not just Rails. And there are 2 principles here. The first one comes from something that my mom used to tell me. She would say, don't do tomorrow what you can do today. But actually, I'm going to teach you the opposite of that. That's not the principle. The principle is, don't do now what you can do later. So, for example, let's imagine we have a registrations controller. The user registers, and we send them an unwelcome email. I want you to focus on this line. Deliver now? Do we need to deliver this email exactly now? Probably not. So, don't do now what you can do later. That applies to sending emails, to collecting statistics, maybe processing pictures, etc. Talking about pictures, let's say you have a user model, and that model has an avatar attached. And maybe on a controller or on a model method, we delete that file. Do we need to delete that file exactly immediately now? No? Then do it later. Okay, let's explore something different. Say you have a team model and a player model, and a team has many players. And we have this dependent destroy association, which means that when we destroy a team, we first delete all of its players to destroy the team. If you have a lot of associated records, that can take a long time. And if that sounds bad to you, you can try destroy async. And what it does is, when you delete the team, now Rails will enqueue a job for you, and that job will delete the associations, basically. So that's the first principle. Don't do now what you can do later. But, and here comes the second principle, don't stand still. Don't wait doing nothing. And basically it means like, take code that visually executes like this and take it to run like this. So let's start with some examples. We'll start with HTTP requests. So let's pretend we have this Twitter newsletter class. It takes a bunch of tweets and creates a newsletter. And creating the newsletter is basically generating a summary for each tweet and joining all of that into a single string. And in this app, we are using AI to generate the summary for us. And in real life, there would be an HTTP request, but for this presentation, I'm going to use just a sleep call because it's easier to benchmark. So if you have 2 tweets and you measure the time that it takes to create the newsletter, it's 2 seconds, because we are mostly waiting on I/O, waiting on that sleep call. We can do those requests that we are sleeping in this example in parallel. Basically, that's everything that we needed to change using the async gem. Basically, we have to wrap the code in this sync block, and for each summary, we generate it inside this async task. And then we wait for all the tasks to complete. Running the same code, the same benchmark again, it's running in 1 second, because we are executing all of those requests in parallel now. The cool thing is that this works for 2 tweets, but say if you have thousands of tweets, that would still take around 1 second. And for those asking if this is like a real thing, use it in real life, this is an app that I have, a gem, that does a lot of HTTP requests, and using that, I was able to make it 10 times faster. So yeah. In fact, we can do the same thing with database queries. So let's pretend we have this reports controller. And this controller does a bunch of database queries. Again, the queries are all they do is sleep for 1 second. And if you look at the logs, you would see this, each query taking about 1 second to run. And the total time is 3 seconds. But we can make those queries in parallel since Rails 7 using this load async method. And they would execute like this. You are waiting in parallel. So to do that, it's pretty simple. All you need to do is take your queries and add load async at the end. You do have to have active job configure. And if you look at the logs, you'll see that they are different now. First, we see that the queries ran async. Then we see the time that each query took on the current thread. So only the first query ran in the current thread. The other ones run in different threads, so basically 0 milliseconds here. But lastly, we see how much time it took on the database. So you see that each query still takes around 1 second on the database. But the total time now, it's 1 second. We just got 3 times faster with a simple change. And I know what you're thinking. Let's do all queries async. But I have to tell you, that would actually make things worse. And that's because of this thing called the thread pool. You know that the thing that you configure, that's the database thread pool. And I want you to think the thread pool as like a box of controllers. And each controller is used by one user, one request, generally speaking. But when you have load async, now one user might use several controllers. And what if the user uses all of the controllers available? Well, the other users will have to wait if they don't like waiting. So be careful using load async on busy routes. A good use case, though, is like when you have an HTTP request and a database query at the same time, so you can basically do them in parallel. Okay, let's talk about lazy loading now. And more specifically, is basically async views here. Imagine you have this dashboard page in your app. It has a bunch of data, a bunch of charts, and they have a bunch of queries generating those data. And let's say one of the queries takes like 10 seconds to run. And you think, let's load that async now. But the whole page would still need at least 10 seconds to run either way. So one way that we can improve on that is using lazy loaded turbo frames. They work like this. The user is seeing a part of the page, and when they finally get to see the turbo frame, Rails will load a new part of the view, and it will get the new part of the view and replace the old one with that, so the user has an updated page. To do that in code, basically, instead of just rendering whatever you need, now you use a turbo frame, and you give it an ID and a source. And a source basically means what's the route where you are going to fetch that content from. And we mark it as lazy loaded, which means that we only load this content when it's on the viewport, when the user is seeing that part of the screen. Then you can implement the controller as you would normally. The query will still take 10 seconds. And you render your views as you would normally, but you wrap them in the turbo frame with the same ID that you specified earlier. So again, when the users see the part of the page, Rails will load that in a separate, and we'll get the turbo frame with the new content and replace the old one with the new one, and we'll get the updated content. What that does is, instead of waiting 10 seconds to see content, we can load content right away and maybe that's the part of the page that you were interested in, but only the users that scroll down to the slow part will have to wait those 10 seconds. So remember that I talked about principles. That's where you start applying them. You can do the same thing with JavaScript. If you don't need JavaScript to load your page, just load it after, load it async, and start showing stuff right away. You can do the same thing with CSS. You can extract the most critical, most important thing in your CSS style sheet, like the stuff that show right up as you load the page, and then you can load the rest of the style sheet later. You can do the same thing with fonts. You can have this special attribute, font display swap, which basically lazy loads your font. So your page basically will load with whatever font the user already has on their device, and then later they get the font that you wanted. You can lazy load images. So basically, you only download images that are currently being seen. So this will save data for the user and saves rendering time. There's even a Rails configuration to lazy load all images by default. All of that will make and help your page show content right away instead of seeing that blank screen for hours. Okay, lastly, I want to talk about some of the async developer tools that we have. Everyone likes Postgres. It is a great database. But it has this annoying behavior by default that when it's writing an index to a table, you cannot write to that table. So if you have a large table and you are trying to index a column, the table might be unusable for hours. And that's just not acceptable sometimes. So one way to work around that is using the concurrent algorithm to add index on Postgres. And what it does is that it allows you to add an index and read and write to that table at the same time. But there's one caveat that it will make your database slower during that time, but slower is better than unusable. Talking about slow things, Rails can help you with your tests. If we have, since Rails 6, you can run your tests in parallel. Basically, all you need to do is say how many workers you want. And you can let it figure it out by looking at the number of processes your computer has. Because tests are running parallel, basically, the more workers you have, the faster the test suite will be. Unfortunately, this is not available for RSpec by default, but before you get set, there are several gems that implement this for RSpec, and this is one of them. I wish I could say that async programming was all fun and all roses all the time, but I need to talk about the pitfalls. And they all come down to this principle that with great power comes great responsibility. When you start writing async code, you have to think about async now. You have to think about the thread pool. You have to think about race conditions. And usually, we are just not used to doing that in Rails. So code can feel harder to understand now. Errors will become harder to debug. And it just might feel like you have less control over what's happening. So before you take the train to async land, I want you to make sure that you have the basic performance things sorted out. I'm talking about like you added index to the database. You fixed the n+1 queries. You are using caching, view caching, and low-level caching where needed. It means that you are writing good Ruby. You are avoiding writing bad Ruby like this. So for example, you are, instead of map, then flatten, you can do a flat map. And you can do that with the Rubocall performance gem that will catch all of that for you. It also means that you are generally avoiding writing code that takes exponential time to complete. Because the thing is, no amount of async programming will help if the code that you write takes longer than the age of the universe to complete. But if you did your homework well, then yes, async can be the ticket to speedland that you were waiting for. That's it. That's all I got for you today. I hope you enjoyed this.